welcome again to this channel. Today we'll be solving LeetCode question number 611 and that is marked medium. Let's understand what this question wants us to do. So we'll be given an integer array nums. We have to return the number of triplets chosen from the array that can make triangles if we take them as lengths of a triangle, right? So basically we have to return the number of triangles we can make using the numbers available in the nums array. Okay, now let's see an example. This is an example test case, and basically we'll have to pick three numbers. Let's say we pick 2, 3 and 4. We have to make sure that 2, 3 and 4 are the valid sides of a triangle, right? How do we do that? We have 2, 3, 4, right? So basic condition for a valid triangle we all know from school is that sum of any two sides must be greater than the third side, right? So that means 2 plus 3, if we sum 2 and 3, the third side remaining is 4, right? So it must be greater than 4. Same with the other sides, 3 plus 4 should be greater than 2 and 4 plus 2 should be greater than 3. In this case all these three checks satisfy, and that's why the numbers, basically a triangle made using these numbers such as length of sides, will be a valid triangle, right? Now this seems a bit too long of a check, right? Checking all the three conditions. So what we can actually do is, so three numbers, right? 2, 3 and 4, we need to make sure all the three conditions are met. So what we can actually do is use 2 plus 3, right? Why? Because 2 and 3 are the smallest out of the three available numbers, right? So the sum is 5. So that means the sum of 2 and 3 will also be the smallest sum possible. The other sums are 4 plus 2 equal to 6 and 4 plus 3 equal to 7. So as you can see, out of these three, the smallest sum is 5, and that is of 2 and 3, right? So that means if 5 is larger than 4, what this says is smallest sum is larger than the largest side, right? So if the smallest sum is larger than the largest side, the larger sum will definitely be larger than the other smaller sides, right? So with this one single condition, we can check whether a triangle formed by the three sides is valid or not, right? And if you see this, you should have guessed that we need to sort the array. That's how we can ensure we get smallest and largest efficiently, right? So the first step of solving this question is to implement or is to sort the array. So as you can see, I've already written the code of heap sort. Now if you don't know how a heap sort works or don't know how to write it in Golang, check out my other video. There I've explained how a heap sort functions, right? So I'm not going to go into detail of the heap sort here. So the first step was to sort the array, right? So m nums, and we will sort the nums array, right? Now we need to pick three sides, right? We need to choose three numbers so we can check if the triangle formed by those three numbers are valid or not. So let's write the logic for that and I'll explain it later. Okay, so we'll say for k n minus 1, k greater than equal to 2 and k minus minus, and this is the first number, and the second this other two numbers would be I equal to 0 and j equal to k minus 1. So what this means, let's see that. So let's take an array of numbers, say 1 2 3 4 5 6 and 7, right? The indexes of these would be 1 0 1 2 3 4 5 and 6, right? Now as you can see, we are starting k from n minus 1, that is the last position. So k would be here, right? And we are starting I from the first position, that is the 0th index, right? I is 0 and j is 1 less than the k, so j would be here, right? How does this help us? Because as I said, the condition was to check smallest sum larger than largest side, right? We need to have the largest side available. That is done by k, that is done by k, and we'll see how I and j helps us when we dry run the code, right? But the largest side is ensured by k. So these are the numbers that we have selected, right? 1, 6 and 7. K is here, j is here, and I is here. I'll write those I, j and k, right? So let's see how we'll check 1 plus 6 is greater than 7. 1 plus 6 is 7, greater than 7. This is not true. This is not true. So now we can either move I or j. I moves forward, j moves backward, right? So what will we choose? Will we move I or will we move j? Think logically. We need to make this condition true, right? This is not changing because this is the value of k. This is the largest side. We need the largest side, right? So this is fixed, right? For this side is fixed. That means we need to change this side, right? Now this is composed of 1 plus 6. That means in this side as well, we can either choose to change this or this, right? Now if we choose to change this, the only possible way for j to change is move in this way. And since the array is sorted, we definitely know for sure that if j moves backward, the only numbers it will get are smaller and smaller. Now since we need to increase this, right, we need to increase the number 7, making j smaller does not help. That means in this case, if a condition is not satisfied, we have to move I forward, right? So let's do that. We'll move I here, right? So till now we have not found a single combination that is a valid triangle. Now we have moved I, and the new combination it becomes is this: 2 plus 5, sorry, not 5, 2 plus 6 greater than 7, and that gives us 8 greater than 7. So this is a true condition. That means this combination of numbers 2 comma 6 comma 7 is a valid triangle, and we can increase the count by 1, right? Count now becomes 1. That this is simple, right? Now what comes after is the true logic. So this means at this point, when I is at 2, j is at 6 and k is at 7, we have a valid triangle, right? Now if we keep on moving I forward, the I will keep on getting bigger and the sum will also get bigger. So that means for every I from this point onwards till it reaches j, basically before j, till 5, this all is a valid pair, right? All these are a valid combination. That means the different combinations would look something like this: 2 comma 6, 2 6 7 is a valid combination. The next combination will be 3 6 and 7, then 4 6 and 7, and then 5 6 and 7. We cannot reuse, so it cannot be 6, 6, 7. But these are all the valid combinations, right? So how many are those? They are 4 of them, right? Now if you look at the position of j and I, j position is 5 and I position is 1. And how many count did we get? 4. 5 minus 1 is 4. So in the count, what we need to do is j minus I. Count plus equal to j minus I, right? Now we had this array 1, 2, 3, 4, 5, 6 and 7, right? So the last combination was I, j, k. This was the last valid combination we found 5, 6, 7. So this was the last valid pair we found 5, 6, 7, right? But remember, I never moved to 5. I is still here. J is here, right? Now at this point we have counted up to here. Okay, we are done counting all these combinations. So what we do, instead of moving I, we now move j backward. I think logically this also makes sense because we have used every possible number 2, 3, 4, 5 in combination with 6 and 7, right? So the next logical thing that can form a combination is I is at 2, right? So maybe 2 slash 3 slash 4 comma 5 comma 7, right? K is still fixed because we have put k in a loop. So k will reduce, it will become 6 eventually. But for now, since we are done with 6 and 7 as fixed, the next logical thing is 5 and 7. And you might think why we are not resetting I to the initial position. That's because this is the smallest number. If the smallest number possible could not form a combination with the largest number possible, 1 and 6, because 7 was fixed, so the smallest number and the largest number could not make a combination, valid combination. Do you think a number smaller than the largest can make a valid combination with the smallest? Their sum will even be smaller, right? But we want larger sum. That's why I is also in the correct position. And the loop continues, right? So what we have seen is if I, that means value at I plus value at j is greater than value at k. If there can be two things, if this is true or this is not. If this is true, we reduce j minus minus, and before that we do count plus equal to j minus I, right? We count every combination from I till j and then we reduce j. If it is not, if it's not, then we move I forward. This makes sense because, so why did we increase I? I've already said, because if their sum is not larger than k, then we need to increase the sum, right? We need to increase the sum. J is already at the largest possible value and j will only reduce if j moves backward, so we'll move I forward, we'll increase the value of I, right? So this is our entire logic. Let's code it out. We've already selected the numbers. The check was if nums of I plus nums of j larger than nums of k. If it is true, then what do? We increase the count, and by how much? J minus I, and we reduce j as well. Else, if it is not true, this condition is not true, then we need to increase the sum, right? Because it is not currently not larger than this side. We need to increase the sum, and for that we'll increase I, and we simply return count. Of course we need to initialize count as well, so count equal to 0. Okay, something went wrong. That's because we are only checking this once. What we need to do is for I less than j, then we need to check it. Let's format it. Also, you have understood why k is greater than equal to 2, right? That's because we need ij and k, right? So that means if k is here, then I will be here and j will be here. But if k is here, j is here, I has no place to go. So the last possible place k can be is this index, and this is index 0, 1, and 2. That's why here we have written k greater than equal to 2. And as you can see, the answer is correct. The code is working. So this was a solution for this question. Thank you for watching, and I'll see you in the next one.